Yeah, it's a thing.
Alright, open tray function. This function will simulate the mechanical error of the ATM tray in random. Since we are saying about random, of course we are gonna use as runtime and random percent yada yada. So here the flowchart, which is as runtime is necessary to ensure that the generated random numbers are not the same every time the program is run. And then we are using if assertion. In this random percent, this operation will give us a number that is either 0 or 1. Since we are making the condition is equals to 1, so if it true, if the result is 1, it will return tray normal, which is this represent the successful opening of the tray. And otherwise, if it not equals to 1, it will return tray fail, which is represent the failure to open the tray due to mechanical error. Alright, insert token function. The purpose of this function is to prompt the user to insert their money and update the token amount accordingly. It has 4 parameters, pointers to variable token 10, token 20, token 50, and token 100, which are used to store the amount of tokens for each denomination, 10 ringgit, 20 ringgit, and so on. The function starts by displaying a message asking the user to insert their money. It then prompts the user to enter the amount of 10 ringgit tokens by using the scanf function to read an integer value and store it in the memory location pointed to by the token 10 pointer. The same process is repeated for 20 ringgit, 50 ringgit, and 100 token. There is no return value for this function as the token variables are updated by using pointers. This is the function display deposit. It takes 4 parameters, token 10, token 20, token 50, and token 100, which represent the number of tokens deposited for each denominator. And the function calculates the total amount of money deposited by multiplying the number of tokens for each denominator with their respective deposit value and summing the results. The result is stored in the total variable. The function then prints the amount of money deposited for each denominator and the total amount of money calculated from all denominators. Lastly, the total variable is returned as the output of the function. Next, deposit money. In this function, we calculate the new account balance after deposit process. This function takes 2 arguments, which is total money deposited, which is an integer representing the amount of money being deposited, and account balance, which is an unsigned integer representing the current balance in the account. The function calculates the new balance after money is deposited by adding the total money deposited to the account balance, and then the result is being returned. Right, let's move on to start deposit function. In this function, we use to simulate the process of depositing money into a machine with 2 accounts. Here's a breaking down of what the function does. The function starts by opening the tray and checking its status. If the tray is normal, the function continues. Otherwise, it prints an error message or return deposit failed. The user is then asked to choose an account to deposit money into, with option for account 1, account 2, or going back to the previous menu. The user's choice is stored in the account selection variable. Based on the user selection, the function sets the balance variable to the balance of the selected account. The function then enters a loop where it repeatedly asks the user to insert money until the user confirms that the amount inserted is correct. During each iteration of the loop, the function calls insert token to get the number of each denomination of money inserted, calculates the total amount inserted using display deposit, and then asks the user if the amount is correct. If the user indicates that the amount is not correct, the loop repeats. Once the user confirms that the amount inserted is correct, the function prints the account balance before and after deposit using the deposit money function to calculate the new balance. The function then returns deposit success. Overall, the start deposit function provides a clear and user-friendly interface for depositing money into a machine with 2 accounts. The use of a loop to repeat it repeatedly ask the user to insert money until they confirm the amount ensures that the user has the opportunity to correct any mistake they make. Alright, Bismillahirrahmanirrahim. We're gonna explain about withdrawal function. So first, enter withdrawal amount. In this function, it will allow the user to select a fixed amount for withdrawal or enter any custom amount. So of course, at first we are gonna display the amount given, and then we require the user to enter the choice. And then after they are making some choice, and we are using switch statement to set the withdrawal amount variable based on the user's choice. Like if the users enter option 1, the withdrawal amount will set into 100, and then it will break. When I say break, it means that it will not go to the case 2, case 3, and so on. It will just go directly to the directly to the return withdrawal amount. And then same goes to if users are entering option 2, it will go set withdrawal amount to 150 and then return. But if the users choose option 7, they are prompted to enter a custom amount. If the users enters an invalid choice, which is default, the function calls itself recursively to prompt the users again, like that.
Alright, let's go for the next part. In this function, we are currently at check current balance. The purpose of this function is to check if the user's account balance is sufficient to cover the withdrawal amount. It takes two arguments, which is withdrawal amount and account balance. And in this function, we are using if else selection, which is it will check if the withdrawal amount is greater than account balance. If it's true, it will return balance insufficient. But otherwise, if the withdrawal amount is lesser or not greater than account balance, then it will return balance sufficient. Then the function will be terminated.
Alright, next, check vault money function. In this function, we'll simulate the amount of money available in an ATM's vault and checks if there is enough money to fulfill a withdrawal request. So, how do we do it? Since we are gonna make it random situation, we are using SRAM time. By using this, it will make the random number generator with the current time. And then we are making random percent 10,000 plus 10 to make it it will generate a random integer between 10 and 10,000 inclusive to simulate the amount of money available in the ATM's vault. After that, we are using if else statement to check it out. If withdrawal amount are greater than vault amount, it will return vault insufficient. Otherwise, if the cases are withdrawal amount lesser than vault amount, it will return vault sufficient. Right, next, dispense money. This function is quite simple, which is we have two parameters, withdrawal amount and account balance. First, we gonna print the current account balance before the withdrawal process. And then we calculate the new account balance by subtracting the withdrawal amount from the current balance. And lastly, we return the new account balance after we are subtracting it. Right. Start withdraw function. Start withdraw function is quite crucial, which is without it we cannot enter to this module. And then firstly, of course, we're gonna allow the user to select their account that they want to make withdrawal process. And then in this function, we compile all the function needed to make sure we can run the withdrawal process smoothly. Dispense money, withdraw amount, and then vault, check vault, and so on. So here our flowchart for the start withdraw.